let's talk about the opposites. Okay, so in algebra, we know the opposite of addition is what? Subtraction, right? Opposite of subtraction is addition. Opposite of multiplication is what? Division, and vice versa. Okay, so the calculus, the skills used in the calculus, it's like derivatives. It's like subtraction. It's reducing, smaller. Then antiderivative. Opposite of derivatives, we call it antiderivative. It's like addition. You keep adding things. So it's a two opposite skills. Okay, so that's how we calculate. In algebra, we just do add subtraction. But here in calculus, we do what? Derivatives and antiderivatives. Okay, so we did derivatives. That means we are doing the reducing. And like if you take a polynomials, right? Then when you take a derivative, it drop one level lower, then you move the coefficient to the front, right? And we have constant rule, the power rule, right, on your page 44. Then this one is what? Constant multiple rule. Then you can take a constant out, then you just do the derivative for the function. Then we have what? Sum difference rule. When you add, subtract polynomials, you just do it individually and put it together. Then for exponential function, for e to the x power, we use base e usually. We don't use other things for the purpose. Okay, so the derivative of an exponential function is itself. If you have a k here, you have extra thing at your regular x place, then you need to use chain rule. When you take a chain rule of the kx, then that will be, because we have what? D dx. If e to the f of x power, we need to do what? For e to the f of x, it's itself, for anything e to the power, but you have to do the chain rule of the function of f of x in turn at the what? The f of x place. So here is kx. You take derivative of kx, become k. That's why we move the k outside. Right? Okay. I just need to double check the page 44. Make sure they are written correctly. Right, that's what I thought. Okay, so I should have k here. Right? You need to fix your answer key for this. Because anything e to the some power, right, kx, you should have the same thing, e f of x. So it should be e to the kx power. Then you take a derivative of f of x, then that would be k. So you put it to the front. Right? Okay? And for the natural logarithm, natural log, right? ln of x. So how do you do the derivative for the natural log? and you just 1 over whatever inside here, then you just do the 1 over x, if it's x. If it's f of x, then you need to use the chain rule, so 1 over x, right? So it would be what? F of x would be 1 over f of x. Then take a chain rule on the f of x. It would be f prime of x, right? Then you multiply them together, would be f prime of x over f of x. Okay, so we are reducing to one level lower, okay, for the derivative. Then antiderivative is opposite of the derivative. It goes back to higher level. That's what we are going to do. So it's 2 major skills on the calculus. One is reducing, one is add them back. We call them what? Integral. Okay, for adding them back. So we can call them what? Antiderivatives. Let's see how we can do that. Then let's just see some examples from here first for the polynomials. Okay, so if I have situation like this, a poly, right, to the second power, or I have x squared plus 4, x squared minus 13, just x squared thing, and some constants, right? If we take a derivative for any of those, d of dx for any of those, then what do we have? Then constant by constant rule will be 0, so x squared take a derivative would be what? 2x, right? So if I do the antiderivative, what should I have? My antiderivative will be what? So I will have antiderivative will be, let's see, we use this symbol for the antiderivative. Okay, integral symbol. Okay, if I do 2x, that means, okay, so let's identify the signs, the symbols first. So this one would be what? Integral sign, right? Symbol. Then the inside we call it what? Integrand. Okay? Then if we do this, and what should I have? I should have what? Because I'm doing the opposite, going backwards. From here, I do derivative, I get 2x. And if I do the antiderivative, going back from 2x, I should go back to all those things, right? That means I should have is what? I should have x squared, because everything has x squared, and with a constant c there. Is that right? Okay. Then if I do this, if I do the integral just for x, right? The basic polynomial for 1 power, this one is 2. So I do just 1 regular x for the polynomial with base x, power is only 1, right? So when I go back, I should have half of this guy. Is that right? Right? So I should have half of x squared plus c. C divided by 2. Still a, arbitrary number. This one is just arbitrary. Constant. Okay? So, we are doing what? Antiderivatives. If I take a derivative of this guy, then x squared derivative is 2x times half become x, right? The constant derivative, constant rule will be c. For the c will be 0, so that will be gone. So if you take a derivative of this, that will be this guy, right? So for any square things, I take a derivative become 2x. If I take antiderivative of x, I go back to the higher level, one level higher, right? Okay, then if I have to the x cubed, right? If I take a derivative of this, x cubed, right? So I should have what? 3x squared. Is that right? So what do I have? Is if I take antiderivative of this, right? If I take 3x squared dx, right? I take a derivative of this would be, take a derivative of this would be this. I take an anti, then I should go back to there, right? X cubed. At the same time, I will add an arbitrary constant, because you take a constant derivative of constant, that would be 0. So it's invisible constant there when you take a derivative. Okay? So what we have here is, if we have this one, x squared dx, so we should have what? 1/3 of this, 1/3 of x cubed plus c, right? So you take a derivative of this will be 3x times 1/3. That would be what? X squared. Okay, so we are checking all the basic polynomials for x squared, x cubed, how about x fourth power, right? Then you take an antiderivative of that, x fourth, that would be what? You take a derivative of that, would be this, right? You drop one level, move the coefficient outside. Then if we take antiderivative of this, that would be what? Go back to x fourth power plus c, right? So what do we have? We have this guy, right? If I take x cubed dx, I go one level higher, right? But I only have quarter of this, would be 1/4 of x fourth plus c. Okay, then if we do the x negative 2, okay, same thing, we use the power rule, right? Drop one level, so dx for this one, that would be what? -2, drop one level, -3, right? So what do we have? If I do opposite, -2x to the -3, right? I do antiderivative, then I go a level higher, right? So -3, one level higher, it goes back to x -2 plus c. Because you take derivative is this one, antiderivative, you come back to here, right? So if I have this one, for -1, x -2 dx, what should I have? I should have one level higher, right? At the same time, divided by -2. Okay? So I should have -3, not -2. So if I have a -3 here, right? I go back one level higher, will be x -2. But I have to divide by -2. So I should have negative, I should write this way, -half, one level higher, -2 plus c. Okay, I'm doing the negative powers. Okay, so the conclusion is this way. What do we have is we are saying if I have x to some power, okay? See, if it's 1, then turned out it's 2. Then you divide by 2. You go level higher, then you divide by that power. You go square, you go level higher, then you divide by 3. 3, you go a level higher will be 4, you divide by 4. Because you multiply this, right? When you move the coefficient outside, then you cancel out your denominator. That way, then you get the things inside the integral, right? Then we say, what will happen if I do the integral of xn power? I should go a level higher, right? But I have to divide by its power. Instead of when we take a derivative, we multiply by its power, right? Then you drop one level lower. When you do the anti, you go a higher level, then you divide it by the power. Totally opposite. That one derivative is go a level lower, multiply its power. This one is what? Go level higher, then divide by its power. At the same time, you need to add an arbitrary constant, because you take a constant, derivative of constant is 0. So the inside, the antiderivative should still be the same, right? However, there is an issue is what? This condition n cannot be 1. Why? If n is 1, n cannot be -1, right? Cannot be -1 because -1 plus 1 make the denominator 0. When you do antiderivative for x next 1, if you follow this rule, then that would be x0. Then, but you have to divide by 1 over -1 plus 1 is 0. You cannot make a denominator 0. So we cannot use the what? This one we'll call it power rule. power rule, you go a level higher, right? So if this situation, you cannot use the power rule. Okay, so what did we just do? We just did what? Antiderivative of this one for the basic polynomials. All right. So instead of you drop one level, NT, you go a level higher, right? So we just did this one. Is that right? For the basic polynomials, except n is not -1. If x -1 power, we cannot use the power rule, right? So just right here, okay? So what are we saying is this one dx, you cannot use the power rule, right? That's what we were talking about for the antiderivative for the power rule. Okay? Then, let's see. Then for the constant rule. So, look at your page 64. Okay? So, for the constant, right? Any constant, take a derivative is 0. That means we are talking about this, right? If I have a d dx, they say 5, then that would be 0, or d dx, say 7, that would be 0, right? If I have, we started from x squared, take a derivative become that. What happens if I do d dx for the x? That would be what? 1, right? So if I wanted to do the antiderivative of some basic numbers, just a number, so I'm going to do the what? If I do antiderivative of 1 dx, right? This one is the integral symbol, means this integral symbol and this dx thing, means you are doing it against the variable x. So if I go back from 1, I should go back, because this is a 0 level, right? So you go back 1 level higher, you should have x, then plus an arbitrary constant, right? So we are talking about integral a number. If any number, that means what? It means kx, because if I do d dx of kx, I should have what? 1 level lower will be constant 1, so be k. So if I do the constant, a number, right, k, I should go level higher. That's x to the 0 power. 0 level, higher power would be 1 plus c. Okay, so another constant for the integral of a constant So we should have what? 1 dx, that should be x, or we can have integral any number, then that would be kx. Okay, it's a different, we call this constant rule. It's different from here. Okay, constant then becomes 0. If you do the integration of 0, that would be your constant. So, but for integral property, the rules we should have is for any constant. Actually, is what? This one is 0 level, right? Then you go a level higher would be x. Oh, where is my c? Okay, I need to add the arbitrary constant as well. Okay? Then for if you have like this one, right? If you do antiderivative of what? A number times f of x, okay? It's the same thing. You take the k out, then do f of x of dx, okay? So I should have dx here as well. Okay, so this is a constant rule. It's like your derivative. If you have constant before the derivative, you can take the constant out, right? Then take the derivative of f of x. When you do the integral, same thing, you can take constant out, then you just do the derivative for the function. Then we call it constant rule. Okay, constant multiple rule. Same thing if I have, those are, so this one is kind of equivalent to this. Okay, and if I have the antiderivative for two functions, add or sum of the dx, f of x plus or minus g of x, then antiderivative of this is the same thing as I do it individually. Okay, it's similar thinking as that one. Okay, so we call this on your page 64, then we call this power rule for the antiderivative. This is the constant rule for the antiderivative. This one will be constant multiple rule. Okay, this one will be sum and difference rule for the antiderivative. Okay, so for antiderivatives, we have similar rules like derivatives. We have constant rule, but over there is for antiderivative. Then we have power rule. Then for antiderivative power rule, we have what? Constant multiple rule. Then we have constant multiple rule similar to antiderivatives. Then we have what? Sum difference rule for the derivative. Same thing, we have what? Sum and difference rule for the antiderivatives. Okay? Now let's look at the exponential function. Then we do antiderivative for those. Okay? So let's look at the property. If we do antiderivative of this one, right? For the exponential function, so the basic one for this one, that would be, same thing, right? So your antiderivative, if it's EX, then you just go back to EX, right? But if you have this one, what happened to antiderivative e to the kx power? Okay, so let's do the derivative first. Let's see what will happen. So if I'm doing the derivative d dx to the e to the x power, right? Plus a constant, an arbitrary constant. Then I will take a derivative of this. That would be what? You have k e to the kx, then c will be 0. Right? So if I do the antiderivative, this one, from here, that's the result, right? I do the antiderivative of this, I still keep the same, but instead of multiply k, I only have what? 1/k of it. So I will have 1 over k e to the kx plus an arbitrary constant. Okay? So for exponential function, what happens if I not only regular e to the x power, when I do the antiderivative, I have something kx power, which is quite often for our applications. What? Oh, I need to plus c here, right? Then what should it happen? I should divide it by k instead of multiplying k for the derivative. Anti, I do opposite. So e to the xk power plus c. Okay? So that's our antiderivative for the exponential function. All right. So one more is what? Log function. How we are going to do it. See, for the log function, right? We said, we did a review in the first week. We say inside the log cannot be negative. So x has to be what? Bigger than or greater than 0. Right? Take a look. When we take the derivative for the log, natural log, it ends up is what? 1 over x, which is what? X negative 1. Is that right? So, what does that tell you? If you do the antiderivative of negative 1, right? We say, can I use the power rule? Say, go level higher and divided by the level, right? Then negative 1 plus 1 is 0. You cannot divide by 0. So we cannot use power rule. But take a look. If you take a derivative of natural log, it's actually is what? Negative 1. If I do NT, I should go back where I started. Right? So what should I have? I should go back to here, natural log. So I should have a natural log x plus c, right? Plus an arbitrary constant. However, there is a situation we notice that, right? Inside the log cannot be negative number, has to be absolute. But when we do the x, it's a number we don't know it's positive or negative. So when we go back, we should have what? Put absolute value there. Okay? So what we said here is this one cannot use the power rule, cannot go level higher like those, right? Cannot do like those. So it means what? Negative 1 dx has to be what? Natural log absolute value plus c instead. We cannot use this power rule. We have to use what? Natural log rule. Okay? So for the natural log, take a derivative is what? 1 over x. Actually, it's x minus 1. So you take an antiderivative, you should go back to your natural log. Okay? So this one will replace for all the polynomials for the antiderivative. All other powers, you can use the power rule except what? X to the negative 1 power. Okay? So we described all the antiderivatives for the basic rules we used, right? We learned on the page 44. Okay? Now, let's take look the antiderivative. At the same time, we call them what? If we use the symbols this way, we'll call them indefinite integrals. Okay? So, if we do this one, it means what? For indefinite integrals, we are talking about is this. Okay? If I have f of x, d of x equals g, right? I have a function and I take the antiderivatives. I take the antiderivative. Then I go back to another function. It means what? It means if and only if this situation happened. Okay? It means what? If you take a derivative of the outside, right? You should go back to the inside of the antiderivative. That's what we have been talking about. Right? Then let's practice some examples for those basic antiderivatives thing. Okay? let's practice the power rule first. Those power rule. Okay. Any power except the -1, we cannot use power rule. We have to use what? Natural log rule. Okay? So, if we have this one, antiderivative of square root of x, it means what? We need to change everything to the power to do that. All right, so we do this way. X to the half power dx for the integral. We call them indefinite integral because you have an arbitrary constant c there. So you do NT, instead you go a level lower, you will go a level higher, right? So you will go a level higher, which is what? 3/2, right? Then let's just spell it out. So you go a level higher, then you divide it by the higher level, right? Then you plus a constant. So that would be what? This one would be 3/2. Then you divide it by, that would be 2/3. Then 3/2 plus c. Or you can write a what? 2/3, then that's the power, that's the root. Or you can write it that way. Okay, either way would be fine. You can write this, or you can write this. Right? So we are doing what? Power rule for the indefinite integrals. Okay? So first, if it's poly or rational expressions, then you can use power rule. So first, you check. This one x to the -2 power, can we use power rule? As long as the power is not -1, right? So you do the NT, you go a level higher, then you divide it by that higher level and plus constant. So that would be what? X -1 divided by -1 plus c. So that would be -x1 plus c. Is that right? Okay. Look, next one is integral for the t against t. So you do dt against t, right? Then can we use a power rule? Yes, because power is not -1. So you go level higher, then you plus c. Let's look at the next one. If we have u -4th power, do the derivative against the u, then can we use power rule? Because the power is now -1, so we can use the power rule, go one level higher, divided by -3 plus c, right? So we don't leave the negative number in a denominator, so we write it outside this way. That would be your antiderivative. Manageable, right? As long as you follow the rule, you can do the derivatives. Then you should be able to do the antiderivative. Okay, so let's look at the page 65. So we just did this one, right? The power rule. Then let's do some constant rule. Okay, so if I have antiderivative for the 1 against x, if against u, I should get a u. If it's against t, I should get t. But it's against x, I should get x. So this is 0 level. One is what? So actually this is the same 0 level, right? Then what should I do? I go a level higher, so that would be x1 divided by 1 plus c. So that would be x plus c. So that would be your answer for the constant rule. Okay, so we did what? Constant rule and power rule. Then let's do some constant multiple rule. So let's do this one is what? Constant multiple rule. Okay, what it says is if I do antiderivative, I have constant there. I can just move constant outside, then do the antiderivative for the function. Okay, so if we look at this one, antiderivative of 6x squared against x. So we said, okay, if I have constant there, I can take constant outside, becomes this one, right? Then for this one, this function, can I use power rule? Yes, because power is now -1, right? So I will have this one would be what? A level higher, then divided by that level, right? Then plus an arbitrary constant. Then we cleaned up. So what do we have? We have 2x cubed plus c. That's how we use what? Constant multiple rule. Okay? If we have this one, 7 dx, so what should we have? Okay, we take 7 outside, that would be 1 dx. Then we say constant rule for the 1, right? That should be x. So you have what? 7x plus c. Right? Now let's take a look next rule. Let's practice that one. That would be what? Sum and difference rule. Right? So if we have this situation, 3 square root of x divided by 2 minus 2 square root of 2 divided by square root of x dx. How should we do? We say, what do? You have sum and difference. So you separate them and write everything in power, right? So what do we have? We have here is 3 half x to the half power minus 2 to the negative 8. What is that? Negative half, right? Then against x. Then we write it separately by sum and difference rule. So what do we have? We should have 3 half x, the half power against x. Then we have what? minus this guy, right? 2x to maybe half power to the dx. Can we use the power rule for this? Can we use the power rule for this? Right? Because the power is not -1. So at the same time, we can use constant multiple rule as well. Take a constant out, right? Then we take the antiderivative with power rule on this. One level higher will be 3/2, right? Then divided by 3/2 minus what? 2 constant outside. One level higher will be half divided by half, then plus a constant, right? Then 3.5 divided by 3.5 times 2/3, that becomes 1. So that will be 3x to the 3/2 power. 2 divided by half becomes 4. Then 4x to the half power plus your arbitrary constant. Okay? Or you can write it this way. X to the 3rd power, take a square, minus 4x to the square plus c. Either way would be fine. Right? But we don't leave the answer here. We should write this one as what? Take x out. You have to simplify your situation. Right? Because you have a rule, you have to take the root out. Okay? So we are using the constant multiple rule, right? Constant multiple rule. Then you take a power rule to do that. Also, we did what? Sum and difference rule as well. Okay? Next one. So this one you have a multiple. We didn't talk about anything multiply inside, how to handle them. We only did what? Sum and multiple, sum and difference rule, and constant multiple. If you have constant, you can take outside, and power rule. Like this, we don't have a say things multiply together, how to handle. We haven't talked about that yet. So what can we do? How can we just spread them out? You just multiply them out, right? Because they are polynomials. So you multiply this, become what? X squared plus 12x plus 36. You do the FOIL. Don't give me x squared plus 36, right? You need to FOIL them. Then multiply by x squared. So we have x squared times x squared plus 12x plus 36 against x to do the integral. Then what do? Multiply them out, becomes x fourth plus 12x cubed plus 36x squared to do the dx. Right? Then we do sum and difference rule. Then we do constant multiple rule. Then we do what? The power rule individually, right? So for this one will be x fifth divided by 5, right? Just put the coefficient in front of the variables. Then this one higher level to the 4th, then 12 divided by 4, that would be 3x to the 4th power, right? Go level higher, x squared becomes 3 cubed, and divided by 3, 36 divided by 3 is what? 12x to the cube. Then at the end, don't forget your arbitrary constant. For the indefinite integral, we need to do that. Okay? So, what do we just practice? We practice what? Sum and difference rule, constant multiple rule, and power rule, also constant rule as well. Okay? So now we are going to practice exponential function. So let's do exponential function and the natural log function. Okay? So 2 more rules to practice. As long as you remember this, you take a derivative, become the function, then you take the antiderivative, then you should get back to the original function, right? So that's what we are doing. We are doing the opposite of the derivative. From the things being derived, then you do the antiderivative, you go back to that thing. Okay? Or you can look this way. So if I do, or you can look this way. And derivative of that, you should get g of x plus c. Is that right? If you take a derivative of this, is that thing, then you take antiderivative of that, go back to where you was, right? Let's practice 2 more rules. One is exponential function, one is log function, natural log function. Okay, so let's do this. If I have an exponential function like this, right? Like this. We said for the derivative e to the x power, it's e to the x power. But if the power is not that, just x, then you need to do the chain rule. Okay? It was multiply the k outside for the derivative. You do the anti, you do the opposite, you divide the k. So what do we do? So you should have e1 to the x power divided by half, right? Plus your arbitrary. How do you divide it by half? So if you divide it by half, it's some x, then you should do what? Multiply by 2, right? You multiply, it's a reciprocal, divided by half, so you should multiply by 2. So that will be your answer for that. If you have 6e to the negative 3x dx. So we are going to combine what? Constant multiple rule. If a constant there, just take a constant outside, right? So e6. Then you do antiderivative of e to the x power. Then it's not x, you have k, so you need to divide it by k. E to the negative 3x dx, right? So the answer should be negative 2e to the 3x dx. Yes, and plus the arbitrary constant. Oops, we don't need the dx anymore, sorry. We already integrate them, right? So we just did what? We practiced what? Exponential function for the antiderivatives. One more thing we need to practice is the log. That means what? When the power is -1 for the base of x, then we cannot use power rule. We have to use natural log. Okay? So this one, if we have 5 over 2x dx, what do? We have constant, right? So we use constant rule, 5/2, take 5/2 out, then x, 1 over x, which is what? Natural log, to do the natural log integral, right? Plus your arbitrary constant. That would be your answer, right? Next one. So what do? We use what? Sum and difference rule. So you have actually this one plus this one, right? Then for the first one, it's -1 power. You cannot use power rule. You need to what? Use natural log rule. So that will be what? Your natural log, right? Antiderivative. Then for this one, you go, can we use power rule? Yes. One level higher will be what? X -1 divided by 1, right? Plus your arbitrary constant. So final answer would be this one. Right? So we just start to practice the basic skills of the calculus. One is derivatives, another one is antiderivatives. Okay? One is reducing, one is going back. Now, let's see how we are going to apply the concepts of antiderivatives. Okay, let's take a look at the page 66. Some examples. First one, recovering cost from marginal cost. It said, a company's marginal cost function is MC of x equals 6 square root of x, right? And the fixed cost is $1,000. Find the cost function. So that's a fixed cost. So when you see a function with x, you need to find out what does x mean first before you can go any further, right? So here says marginal cost function is this. Then what is the cost function? Because a marginal cost function means what? You are going to use this function to determine what it will cost you more to produce the next item. That's what it means, marginal cost, right? But it depends on the cost function. So what does cost function mean? It means what? It means the cost to produce total X units, right? How much it costs you for total. So cost function is, you know, if X is 1, that means how much it will cost you to produce 1. If X is 100, that means the total cost for the 100 units, right? The item. Then X is what? The units produced. How many of them actually are produced, right? Then marginal cost means at the margin, at that point of time, how much it will cost to produce one more item. That means how much you will expect it costs you to produce the next item, right? Not all the items are same price. So then we know marginal cost is what? Marginal cost function is what? Cost function take derivative of the cost function, right? So we said, how do we find the antiderivative and what do they mean, right? So we say if this is the derivative, if I take antiderivative of that one, I go back to original plus some arbitrary constant, right? So we know marginal cost is C prime of x. So if we want to find what? Cost function, find the cost function. That was the question, right? So cost function is what? Antiderivative of this one, right? It's from here. So okay, we just use equation, right? So that means cost function is antiderivative of a C prime of x, which is what? MCX. Is that right? So what is MCX? You plug in 6 square root of x to the dx, right? Then we say, how do we do the antiderivative? We have bunch tools, right? The rules for us to do it. So this is x and half of x. You have to change everything to the power. If power is half, can we use power rule? Yes, right? Also multiple rule. So we use what? 6 take out. So it's a 6 outside. Then half, we can use the power rule. Go a level higher. Then divided by 3 halves plus something called arbitrary cost. Right? Then what do we have? Then divided by, so 6 divided by 3 half means 6 times what? 2/3. It's 4. So we have what? 4x 3 half plus c. Is that right? Also, we got a piece of information is $1,000 for the fixed cost. What does that mean? Right? We want to find the cost function, but you have an arbitrary constant. You have to find these numbers. Okay? So, what does that mean? And how do we use 1,000 to apply to the situation? Fixed cost means what? Doesn't matter how many units you produce, it will cost you that much, $1,000. Say set up a print or the rental, something like that, right? So it means even you produce 0 item, okay? So then when x is 0, that means what? The cost to produce 0 unit, how much it will cost you? Still cost you $1,000, right? So if you plug in here C of 0, should it be 1,000? So you plug in your function for 0 to the 3 halves, then plus C should be what? Same thing as your 1,000, right? 0 to this power is 0. So what it ends up, that means what? Your C is 1,000, right? So your cost function should be this guy. 4x3 halves plus what? 1,000. Usually, a lot of time, your arbitrary constant will be your fixed cost, but not always. Okay? So you need to check, to take a look. Actually, that's what happens. Sometimes it's not. So, let's look at another kind of situation. Take a look. Next one, recovering a quantity from its rate of change. Let's see. It says the gross domestic product, GDP. We use GDP a lot, right? Of a country is 78 billion and growing at a rate of 4.4 to the negative 1/3 billion dollars per year after T years. Find the formula for the GDP after T years. Then use your formula to find the GDP after A years. Okay, so that's how a lot of economists use this type of thinking to estimate or predict their GDP. Okay, let's see how actually it's done. Say a country has what? GDP is 78 billion. Okay, and growing rate of 4.4 T negative 1/3 billion dollars per what? Per year after T years. Okay, say, okay, some country, that year, they have a total $78 billion GDP. Then we know they have a model said that country grows, 4.4 T negative 1/3 power billion dollars per year. Somehow they did the stats, then figure out, oh, this is the rate, growing rate. Okay, what does that mean? Then we also want to find out, okay, the formula to do the projection, right? After 8 years, how much this country, the GDP will be by the time 8 years later. So, this is the growing rate. So growing rate means what? The rate of change. Usually is by percentage. Okay? So let's do some analysis, try to figure out what kind of things we are talking about. Okay? So if your GDP, say that's your GDP per what? According to the year, so that's your model, right? So if you have this function, you can just plug in T is 1, 2, 3, 4, and on to find the GDP, right? So that's what we want to find. Then we can plug in the model to do the projection, to expect how much income the government have, for the tax revenue and for the, spending as well. So you can plan ahead. All is from GDP. And at the same time, they did a study say that's the growing rate It may not be accurate, but at the moment, that's what it is, right? So usually let's go from here because we know that's the growing rate, okay? So T is the year, is by what? Percentage, okay? That means what do we have? We have growing rate. GDP is what? Your growth, right? Not growth, your domestic product. So the rate of change is this one. That means this is your function. The rate of change is what? Your prime, first derivative, right? That's called rate of change. Then at the beginning of time, we didn't have anything, right? So we started. Then doesn't have growth. Then after a year, we plug in here, right? So plug in 1, so that's 1. That would be what? 4.4%, right? So then second year, let me just write it down. Okay, so from the first year to the second, from 0 year after the first year, you have this, right? From first year to the second year, you will have what? I'm just plugging in the number. You use your calculator, okay, to get all these numbers. 4.923%. Then at the third year, from second year to the third year, grow to what? 3.0508%, right? To the fourth year, you grow to what? 4.4, 3.49, 3.05, 0, 1, 2, 3, 4, plus, this is the first year, this is the second year, this is the third year, short of one number, fourth year, 2.7718%, to the fifth year, you get a 2 point, let me see, 1, 2, 3, 4, 5, 6, 7. Okay, 8, 6, 7, and 8, right? So I just wanted to line them up. So first year, that means I add 4.4%. Then after this, I add 3.4923%. This will be 3.0508%. Next one will be 2.7718%. Next one will be 1, 2, 3, 4, 5. 2.5731% plus 2.414 for 214 plus 2.3001%. Okay, so the GDP growth product is what? Gradually adding to some numbers. Okay, so that's the analysis. So if I do G prime T, okay, so that's a G prime, right? That's 4.4 T to the negative 1/3. Then GDP is what? G of T will be the antiderivative of that, right? So take this one, 4.4 T negative 1/3 2/3 of the dt. Then you do your, antiderivative. So we have 66.6 2/3 plus a constant, right? Then at the year 0, we plug in. So that would be, you plug in t is 0, right? That's a 78, right? At the beginning. So that would be your 78, which means what? That's your C, right? You plug in 0 to here. C means what? 78. So what's your G of T? So your GT will be 6.6 T 2/3 plus what? 78. So that's your function, right? Then how do you find the G of 8 after at the 8th year, right? 8th year means what? After the 7th year to grow. So 1, 2, 3, 4, 5, 6, 7. That's correct. Okay, so at the 8th year, no, after 8th year, so the G of 8 would be what? This would be very confusing. After first year, second year, 3, 4, 5, 6, 7. I need one more, I would think. Okay, so then we plug in 8. What do we have? Then we have 104.4 billion. Okay, according to this model, after the 8th year, we should have 104.4 billion GDP for that country. Okay, so according to this function, let's do another analysis. So this analysis is what? According to the model for the rate of change given to us, right? Okay, since I have the model from the rate of change, I get the GDP model. If I use this model, what does it tell us? Okay, so this is a T, this is our GDP. Then let's just find the difference. Okay, so at the year 0, we start from 78 billion. I'm just plugging here, right? So I plug in 1, I have 84.6 billion. Plug in second year, I have 88,477. And 3, I should have 91.729. 4, after 4th year, I should have 94,631. After 5th year, I should have 97,299 billion. After 6th year, I should have 99.793. Right? Then after 7th year, I should have 102.15. After the 8th year, 104.4 billion. Okay, so I'm going to take a look what happened to their rate of change. Okay, so at the beginning, the difference here is 0.66. All right, then from first year to the second year, then the change is what? 0.8768. From this year to here, that will be 3.2517. From here to here will be growth rate is 2024. Then here it would be 2.6676. Here would be 2. I just subtract them, right? Then what's the difference? 6. So that would be around around 4. If you look at your answer key, you can see all the number it's written down for you. Okay, 587 here is plus 225. Okay, so then if I do the percentage, because the rate of change is by the percentage difference. All right, so the rate of change here would be what? You use this number divided by what? The original number. Okay, so this one is about 4.583%. This one is about 3.675%. This one is about 164%. This one is about 891%. This one is 12.500%. This one is 2.310%. This one is 2.20%. Okay? So what happened is after first year, okay, at the beginning they started from here. So after first year, they start to collect the data. Okay, so after first year, they find out at the beginning they started from 78 GDP when they started. Then they start to develop their model after the first year, right? First year is not enough. Second year, they realize they have what? They increased to the next year. They increased to, they have more 3.8 billion more GDP. Then they divide it by 84.6. That's the percentage, right? So then if you compare the given model somehow to those number according to what we calculated from antiderivative, 4.4, 4.583, 3.49, 3.6, it's close all the way to 2.3, somewhere there, right? Then I don't know exactly how do they develop the model from, at the beginning from years, so after this year, they have 78 to start with. Then after first year, then what happened to the beginning? They don't calculate those. We need to talk to your econ teacher, okay? How the GDP are calculated and how do they actually see it, all right? But mathematically, if the model is given this way, that's the function we will get it from the G prime, the rate of change, okay? So what I do here is just compare some numbers with the concepts of the, derivative and antiderivative. But in content, okay, you need to have work experience, and talk to your econ teacher how it actually work out for you, okay? Then what we do is just doing the math portion, use these skills to do the projection. right? So I would think in the field, then you need to do some kind of adjustment to actually pinpoint the situation, right? Then how good your model is, how close the numbers will close to the reality. Okay? So let's look at the next one, page 67. Here says, finding total flu cases from the rate of change. Okay? An influenza epidemic hits a large city and spreads at the rate of 12 times e to the 0.2 t power new cases per day, where t is the number of days since the epidemic began. The epidemic began with 4 cases, if they started from 4 cases. Okay? They want us to find a formula for the total number of cases in the first t days of the epidemic. And use your formula to find the number of cases during the first 30 days. Okay, so influenza, for most people, it resolves on its own, not like our coronavirus right now, right? Then it spreads at the rate of what? The rate is 12e.2t. That's the model they collect. Just like our coronavirus, they find out, okay, from day 1 to day 2, how many cases more? Then from day 2 to day 3, how many cases more? Then they use those real data to develop the rate of change, how many increase each day it becomes, then give you a formula. It's an exponential change. Growth is very quick, right? So that means what? If this is my rate of change, that means my f prime according to t is your day, right? So first you have to figure out the variable you use, like t, is by days, by weeks, by months, okay? Then we wanted to do projections, say, what happened 30 days later? How many cases that would be if the model remains the same, right? That's a big concern, just like we have now. So then what do? We say your formula is what? If ft take a prime is f prime of t, then you going back means what? You integrate them, you take an integral, then according to the time, you should get ft plus some kind of constant, right? So we want to find out, to do the prediction, we need to find out our formula, total number of cases in first t days, right? So we would do what? The antiderivative of f prime t, then this is exponential growth, right? So we use what? Exponential function, the integral for that, then constant rule. You take 12 out, then this is a point same thing, except you have to divide it by t, right? Then you plus a constant. Then what do we have? we have 60e.02t plus c, right? Then it tells you when they started, they have 4 cases, right? Means at the beginning, day 0, right? At the beginning. So F0 is what? You plug in 0. 60e.20 plus c supposed to have how many cases? 4, right? Then e to the 0 is 1, so we have what? 60 plus c equals 4. That means our c is what? Negative 56. Okay? So your function, that's your ft, right? So your ft would be what? This guy. 60 e to the 0.0t plus what? Minus 56. That's your c, right? So that's our model of the projection for the cases. Because we wouldn't have cases regularly to figure out a model for the cases, we only have what? To start with the rate of change. We only know day 1, how many, day 2, how many, day 3, how many. Then we only know the rate of change at the time. Then we need to find the model for the prediction. Okay? So after 30 days, what do? We plug in 30, right? E.2 to the 30 minus 56. Use your calculator, right? Plug in, so it's about 24.150 cases. So what is saying? It's a very scary thing for this flu. In 30 days, right, the epidemic will have what? We have grown to more than how many cases? 24,000 cases. Just in a month, right? In a day, we are talking about per day. Okay, so it means what? From day 1 to day 2, it changed more, so many cases more. But in 30 days, then you will have, in a day, you'll have so many cases more happened. That's from the model. Then we'll do the prediction for that. Okay? So that's how we will use the antiderivative to do that. Okay? You can do some analysis on your own, then see. That will take too long in 30 days to plug in 30 numbers. Okay? Or you can use a spreadsheet to use what? Excel. Then plug in the formula. If you take your business class, you should know how to use Excel. Then plug in the number, plug in the formula, then it should give you all those numbers. Or you can use calculator, the tablet, the tables things. Then call tutors to do the tables thing. Then, you can use that, then plug in the function, then to see the numbers as well. Okay? Okay, for the example 4, page 67, that's a skip. That question is very confusing. Okay? And look at the page 68, supposed to be example 5. Then on the page 68, you can take a look, and everything is written down. And you can see there is a spreadsheet you can use if you know how to use Excel. You can put a function, calculation on the top. Then it will list all the numbers for you. Then you can just follow the answer keys of your notes to read through, then match all the numbers for your own study. Okay? So that would be our section 3.3 antiderivatives.